Okay, so today we're diving deep into AWS networking services.
Diving deep is right.
We're using this super detailed document as our guide.
Yeah, it's pretty thorough.
And it's going to help us make sense of all the options you have for building, rock solid applications on AWS.
Absolutely. And it's not just about, picking the right services. It's about the philosophy.
The philosophy.
Yeah, like the fundamental thinking behind networking in the cloud. We'll be looking at network designs,
Right.
practical strategies and best practices, and of course, how to make those applications not just fast and secure, but,
Sure.
super reliable too.
Always on.
Exactly.
And what I found really interesting in this document is that it stresses how network design isn't just a technical thing.
It's true.
It has to align with your business goals, your cloud strategy, your overall vision.
100%.
So we need to think about not just what we need today, but where we're going, in the future.
Future-proofing, right.
Exactly, and how all these AWS services can help us get there.
And there are a lot of services. It's a big toolbox.
It is a big toolbox. So to help us navigate, AWS has grouped them into these categories.
Right.
Like network foundations, which are like the core building blocks.
Foundation.
Foundation.
Yeah.
Yeah. So we're talking Amazon VPC, your virtual private cloud,
Right.
AWS Transit Gateway, which is like a cloud router,
Kind of a super router.
a super router, and AWS Private Link for that secure private connectivity.
Inside and outside of AWS.
Exactly. Then there's edge networking
This is how you get your content and your traffic delivered globally.
with things like Amazon CloudFront,
Yeah.
Amazon Route 53,
Your DNS
and AWS Global Accelerator.
for that extra speed boost.
Now, hybrid connectivity, that's huge for so many organizations.
Especially if you're still running on-premises infrastructure.
Exactly. You got to bridge those worlds. And for that, you have AWS Direct Connect dedicated connections.
Right.
Site-to-site VPN, client VPN for secure remote access,
Yep.
and AWS Cloud WAN for building wide area networks in the cloud.
Cloud One is pretty powerful.
It is. Then, of course, security is paramount.
Non-negotiable.
So we have all these network security services, AWS Shield to deflect those DDoS attacks.
Like a shield.
Like a shielded. AWS WAF web application firewall,
Right.
AWS network firewall, and AWS firewall manager,
So many layers.
layers of security. And finally, we have application networking,
Well-
which helps you connect and manage those applications with services like AWS App Mesh, Amazon API Gateway,
For your APIs.
and AWS Cloud Map for service discovery.
It's amazing how comprehensive it is.
It is. And the thing is, all of this networking on AWS is virtualized,
Virtualized meaning.
meaning you're not dealing with physical hardware like in the traditional sense.
Yeah, it's all software defined.
But it's all running on top of this massive global AWS network infrastructure.
The global network.
A global network. And this virtualization gives you so much flexibility. You can create all these different architectures
Right.
based on your needs.
They can tailor it.
You can tailor it. You can have regional isolation, public-facing apps, private internal networks.
You can get really complex with mesh networks or hub and spoke designs.
And the document really highlights three key things about AWS networking.
Okay, let's hear them.
First, it's built on top of that global AWS network we talked about.
Solid foundation.
Second, it's all about those modular building blocks. You can combine them in so many ways,
Like Legos.
like Legos. And third, AWS provides and manages a lot of these services.
Makes things easier.
So much easier. Faster deployment, simplified operations.
Now, as we're exploring all these options, it's really helpful to keep the AWS well-architected framework in mind.
Oh, yeah, the framework.
It's like your guidebook for building solid systems.
6 pillars.
6 pillars. We got operational excellence, security,
It's
reliability,
performance, efficiency, cost, optimization.
and now sustainability.
So important.
It's a holistic way of thinking about building systems, including networks.
Absolutely. And the document also makes sure to cover the AWS shared responsibility model.
Security is a shared responsibility.
It is. AWS takes care of the security of the cloud itself.
The underlying infrastructure,
But you, the user, are responsible for security in the cloud.
your data, your applications, how you configure your network.
It's a partnership.
A true partnership. And one thing that often gets overlooked when you're thinking about network design and costs is data transfer.
Oh, yeah. Costs.
Inbound data coming into AWS is generally free,
That's nice.
but outbound data going out to the internet,
That's where they get you.
that can incur charges.
Absolutely.
And those charges can vary depending on the AWS region you're in.
So important to keep that in mind when you're architecting your applications.
Absolutely.
Another thing the document really emphasizes is tagging.
Tagging every...
Tagging everything. Your network components, everything. It helps you track costs, allocate resources, manage things effectively.
So much easier to find what you're looking for.
And AWS gives you a bunch of tools to manage those costs.
Yeah.
AWS Cost Explorer, the billing and management console, AWS budgets,
For setting spending limits.
and AWS Trusted Advisor.
Your virtual advisor.
It's like having a consultant on call. Then there's the Hybrid Network Lens, which is a framework for evaluating your network design for cost efficiency.
Especially when you have a mix of cloud and on-premises.
Yeah. So, okay, we've got this big picture view. Now let's get into some of the core concepts.
The nitty-gritty.
The nitty-gritty. The document talks a lot about protocols.
The languages of the network.
The languages network devices use to communicate.
Right.
We've got network management protocols like SNMP,
For managing devices.
ICMP for pinging,
To see if things are alive.
then communication protocols like HTTC for web traffic,
The web's language.
TCP/IP, the backbone of the internet,
The internet's language.
and then those critical security protocols, SLTLS for encryption,
To keep things private.
and SFTP for secure file transfer.
Moving those files securely.
So many protocols,
That's
so many languages.
It's a whole world of communication.
And then there's network topology, which is how everything is connected.
The layout of the network.
The layout, we've got point-to-point connections for a direct link between two devices.
Simple and straightforward.
The bus topology, where devices share a single cable. That's kind of old school.
Yeah, not so common anymore.
Tree networks for a hierarchical structure.
Like branches on a tree.
Hub and spoke is super relevant to AWS, often with Transit Gateway as the hub.
The central point.
Then you have mesh topologies, where devices are interconnected in lots of ways.
Lots of redundancy.
And ring topologies, where they're connected in a loop.
A closed loop.
Often you see hybrid approaches combining these different designs.
Whatever works best.
So understanding these topologies helps you visualize how data flows through your network.
Visualizing the flow.
Then there's IP addressing.
The addresses of the devices.
Every device on a network needs a unique identifier.
Right.
We've got IPv4, the older standard, and IPv6 with a much bigger address space.
We're running out of IPv4 addresses.
We are, and the document highlights public IP addresses which are routable on the internet,
So the world can see them.
and private IP addresses used within your internal networks.
Hidden from the world.
It also explains CIDR notation.
Classless interdomain routing.
It's a way of specifying a range of IP addresses
Efficient.
for efficiently allocating address space within your VPCs.
Like giving out addresses in a neighborhood.
Exactly. And then there's subnetting,
Dividing the network.
dividing a larger network into smaller subnetworks or subnets.
For better management.
It helps you isolate resources, improve routing efficiency.
Easier to manage.
And then there's the subnet mask, which works with subnetting.
It tells devices which part of the IP address is the network and which part is the device.
Now, when you're building applications on AWS, you need to store data.
Of course.
The document mentions some key AWS storage services and how they interact with your network.
Right.
For file-level access, you've got Amazon Elastic File System, EFS,
Right.
and Amazon FSX for network-attached storage.
Shared storage.
For block-level storage, like you'd have in a traditional SAN,
Storage area network.
you've got Amazon Elastic Block Store, EBS.
Usually for your EC2 instances.
And the point is, whether it's NAS or SAN in AWS, you need isolated networks with high-speed connections for good performance.
Speed is key.
All of this networking, even though it's virtual, is based on this framework called the OSI model.
Open Systems Interconnect.
It's a 7-layer model that helps us understand how network traffic moves,
From one device to another.
locally or globally.
Doesn't matter.
At the bottom, you have the physical layer
The actual wires and signals.
and the data link layer for reliable transmission between devices,
Direct connections.
the network layer for routing data packets.
Across networks.
Those 3 layers are the media layers.
Right.
Then you have the transport layer.
For reliable delivery and traffic control.
The session layer to manage connections between applications.
Keeping those conversations going.
The presentation layer for data formatting and encryption.
Making the data presentable.
And at the top, the application layer.
What the user sees.
It's what the user interacts with protocols like HTTP and SMTP.
For web and email.
The top 4 layers are the host layers.
So 7 layers in total.
It's a great way to break down network communication.
It is.
The document also compares the OSI model to the TCP/IP model,
The Internet's protocol suite.
which is a 4-layer model.
It combines some of the OSI layers.
And what's really cool is how the document then maps the OSI model to specific AWS services.
Shows you where they fit.
It explains that because networking in AWS is virtualized, many of these layers are implemented in software-defined networks.
Software-defined networking.
So, for example, AWS WEF, the Web Application Firewall.
It operates at layer 4 and layer 7.
Looking at network traffic and application content,
Multi-layered protection.
Amazon API Gateway and AWS Cloud Map, they mainly operate at layer 7.
Dealing with application requests.
Amazon CloudFront, the content delivery network, works across layers 3, 4, and 7.
To optimize delivery.
Even Amazon Route 53, the DNS service, uses layer 7.
With TCP/IP underneath.
To translate domain names to IP addresses.
Right.
And elastic load balancers work at layer 4 and layer 7 to distribute traffic.
Flexible traffic management.
It's amazing to see how these managed services are built on those fundamental layers.
It all comes together.
And the document keeps going. It puts more AWS services into that OSI framework.
Okay, like what?
AWS Global Accelerator improves performance for global applications.
It's like a booster.
It works at layers 4 and 7.
Speed and smarts.
AWS Direct Connect for dedicated connections spans from layer 1, the physical layer, all the way up to layer 4.
A direct pipe to AWS.
Security groups and network ACLs operate at layers 3 and 4.
Controlling traffic.
AWS Private Link for private connectivity works at layer 4.
Secure and isolated.
Gateway load balancers for inserting third-party appliances operate at layer 3.
Bringing in the big guns.
AWS Cloud WAN and AWS Transit Gateway primarily operate at layer 3.
Handling routing.
And within your Amazon VPC, the routing mechanisms and route tables also operate at layer 3.
Keeping traffic flowing.
And the document even mentions that the AWS network infrastructure itself has its own implementation of layers 1 through 4.
It's layers all the way down.
It's layers all the way down.
So this mapping helps you understand how these AWS networking services fit together.
And where they fit in the whole communication process.
It's a valuable mental model.
Absolutely. Now let's talk about Amazon VPC.
The core building block.
The core building block for creating your own private, isolated virtual networks.
In a specific AWS region.
It's a regional service.
Highly available across availability zones.
You get a default VPC in each region when you create an account.
But usually you create non-default VPCs for more control.
More control.
And the document walks you through the components of a non-default VPC.
It's like a recipe.
First, you define a CIDR block.
The range of private IP addresses for your VPC.
Your private address space.
Then you create subnets within different availability zones.
Subdivisions of your VPC.
For fault tolerance.
Keeping things running.
You launch your Amazon EC2 instances in those subnets.
They're virtual servers.
Each instance gets a private IP address from the subnet.
And you can associate public IP addresses or elastic IPs for internet access.
Right.
Traffic flow within your VPC is managed by the Amazon VPC router.
The traffic cop.
And you control that router with route tables.
The rules of the road.
You associate route tables with subnets to define traffic paths.
To get your VPC talking to the internet, you usually use an internet gateway.
The gateway to the world.
For security at the subnet level, you have Network Access Control Lists, or NACLs.
Stateless firewalls.
They evaluate rules to allow or deny traffic.
Simple but effective.
For more granular security at the resource level, you use security groups.
Stateful firewalls.
They remember allowed traffic.
And they have an implicit deny policy.
The document also talks about virtual private gateways for VPN connections.
To connect to your on-premises network.
Or for direct connect.
Dedicated connections.
Now, the document distinguishes between network gateways and routers.
They have distinct roles.
A gateway connects different networks and often translates protocols.
Bridging the gap.
While a router directs data packets within a network.
Based on IP addresses.
But in AWS, these functions often combine into one service.
It's all integrated.
The document lists 7 AWS networking gateways.
7 gateways.
Internet Gateway, Customer Gateway, VPN Gateway, Direct Connect Gateway, NAT Gateway.
Keep going.
AWS Transit Gateway, and Virtual Gateway.
A gateway for every need.
Now, what if you have multiple VPCs that need to talk to each other?
That's where VPC peering comes in.
VPC peering creates a direct connection between them.
Private IP communication.
It can even span accounts and regions.
Securely.
The document gives examples like sharing services between applications.
Or connecting different business units.
But as you get more VPCs, peering can get complex.
Lots of connections to manage.
And there are scalability limits.
So that's where Transit Gateway shines.
Transit Gateway is a central hub in the cloud.
Like a grand central station.
You connect your VPCs to it instead of peering them all together.
Much simpler.
It even does inter-region peering.
Connecting across regions.
And it integrates with Transit Gateway Network Manager and SD-WAN devices.
Powerful stuff.
The cost is based on attachments and traffic.
Makes sense.
Finally, there's AWS Private Link.
For secure private connectivity.
To AWS services other AWS customers, even on-premises networks.
Without going over the public internet.
It's more secure than VPC peering.
Less attack surface.
And it simplifies your architecture.
Elegant solution.
You pay an hourly charge for each VPC endpoint and a data processing charge.
So that's the rundown.
It is. We've covered so much ground.
From high-level services to the nuts and bolts.
Protocols, topologies, IP addressing subnetting.
Gateways, VPCs, peering transit gateway, private link.
The OSI model.
Layers upon layers.
It's all here.
And the key takeaway is that building a good network on AWS requires understanding these concepts.
Absolutely.
And thinking about how they apply to your specific needs.
This document is a fantastic starting point.
It is.
We encourage you to explore the individual AWS services that seem most relevant to your goals.
There's a lot to discover.
And remember, network design isn't a one-time thing.
It's an ongoing process.
You need to keep evolving your network as your business needs change.
And as AWS keeps innovating.
So keep exploring these services and how they can help you build secure, high-performing, reliable, and cost-effective solutions.
Well said.
That's a wrap for this deep dive into AWS networking.
Until next time.